Powered Parachute Handbook 3-2 Components and Systems. Now, let's talk about the suspension lines, those seemingly tangled strings on the powered parachute wing. Each line has a purpose, and they're labeled A through D by some manufacturers. These lines are crafted from robust materials such as polyaramid, resembling Kevlar, or polyethylene varieties like Spectra and Dyneema. These strong compositions ensure the durability and reliability of the lines, contributing to their effectiveness in various applications. These lines connect to risers and help steer the wing. Manufacturers often color-code them to make inspection easier. Remember, the length and strength of these lines are super important. You've got to inspect the wing before every flight, and every now and then, get a qualified technician to check if everything's in good shape. And one big rule, don't mess with those lines. If they're damaged, don't try to fix them by tying knots or splicing. It messes up the wing's carefully engineered flight characteristics, making it not fit for flying. You might have heard them called V-lines. These are like the middlemen between the suspension lines and the aircraft's body, or where the wing connects to the aircraft. Imagine them as nylon webbing straps that include a main cable and a safety cable, all bundled up together. In the good old days, some wings had risers made of braided wire cables. Now, during flight, especially for propeller-driven planes dealing with left-turning tendencies, powered parachute designers play around with the length of these riser cables. By reducing the length on one side, a subtle adjustment is made, and voila! This modification results in a slight turn that effectively counters the torque, preventing any unintended left turns during takeoff. This simple yet strategic maneuver enhances control and stability in flight scenarios. But here's the trick, don't mix up those cables. The left ones are longer than the right ones, and mixing them up could send you on an unintentional leftward adventure. These babies can range from 5 to 20 gallons, and knowing how much fuel you've got is pretty crucial, right? Some tanks are see-through, others are mysterious and dark, but either way, there's usually a sight tube or some gauge to help you keep tabs on your fuel situation. The fuel venting system is essential to prevent vacuum formation inside the tank, ensuring a continuous release of air and gas. This safeguards the fuel system, maintaining optimal pressure conditions and preventing potential issues. Pro tip: keep that vent system debris-free, or you might find yourself in a fuel-starved situation mid-air. You've got 2 or 4 strokes, liquid or air-cooled engines, ranging from 50 to 100 horsepower. Some start with a push of a button, others need a good old pull. Reduction drives play a pivotal role in aircraft, significantly decreasing the propeller RPM to around half or even a quarter of the engine RPM. This adjustment is instrumental in optimizing efficiency and ensuring that the propeller operates at its ideal speed, thereby enhancing overall engine and propeller performance. Thanks to modern tech, these engines are lighter, more efficient, and dependable. And, don't forget the throttle. It's your hand-controlled power regulator. The design might vary between different carts, so always check your powered parachute's manual for the specifics. Propellers serve as the dynamic power converters in the aviation world, transforming the raw energy of engine horsepower into the propulsive force known as thrust. To visualize this, imagine a propeller as a rotating airfoil, similar to an aircraft wing. The principles governing its operation mirror those of a wing, with the shape of the blade creating thrust vectors. This visual illustrating the airfoil sections of a propeller blade. The magic happens as the air flows past the propeller. Pressure differentials on either side of the blade result in a forward force, propelling the powered parachute through the air. In the world of powered parachutes, the propeller's adjustability is a standout feature. Pilots can finely tune its performance, optimizing thrust and efficiency for specific operational needs. This adaptable characteristic adds versatility, contributing to a more tailored and responsive flying experience in powered parachute aviation. Typically, these are ground adjustable, allowing pilots to optimize performance according to the engine manufacturer's recommended RPM targets. However, caution is advised, and any adjustments should be approached with a clear understanding of their impact on powered parachute performance. If uncertainty arises, seeking advice from an experienced source is a prudent course of action. Now, let's pivot to the critical component known as the engine mount. Tailored for each cart configuration, the engine mount plays a crucial role, bearing a substantial portion of the aircraft's weight. This specialized design ensures optimal weight distribution, enhancing overall stability and structural integrity. During transport over uneven terrain or after repeated hard landings, the engine mount faces stress, highlighting the need for robust design. Regular inspections are essential to maintain its resilience and ensure prolonged aircraft durability. This underscores the importance of consistent, detailed inspections before and after every flight to ensure the structural integrity of this vital component. Visualizing the airfoil sections of a propeller blade provides insight into the intricacies of this essential aviation element. Consider the propeller itself, a marvel in motion, spinning at incredible speeds to the point of near invisibility. Despite its unseen nature, respecting the propeller's potential danger is paramount. Always treat it as if it were in an active state and maintain a clear zone around it during all ground operations. Debris, such as rocks or sticks, has the potential to become hazardous projectiles when propelled by the rotating propeller during takeoff and landing. Any damage, regardless of its apparent severity, can significantly impact the overall performance of the powered parachute. For a better understanding, portraying a fuel tank with a sight tube. Shifting our focus to the integral aspect of wheel assemblies, both front and rear wheels form a cohesive unit. This assembly comprises a tire, rim, and inner and outer wheel bearings. Secured on a spindle and held in place by a nut and a cotter pin, the wheels contribute significantly to the overall functionality of the powered parachute. The suspension system, unique to each manufacturer, offers a delicate balance of elasticity and strength, ensuring a smooth ride. Tire preferences, whether heavily treaded or smooth, often hinge on personal choice and the type of terrain encountered during operations. Some pilots opt for additional measures, such as tire sealant or thorn guards, to mitigate the risk of flat tires. In essence, propellers are the force behind thrust generation, engine mounts bear the weight with precision, and wheels facilitate smooth navigation. Prioritizing safety at every stage of operation ensures a secure and enjoyable flying experience in the realm of powered parachutes.